Hey, in this one I'm going to show you how you can use the push-pull pattern in Zeromq. So I have a little diagram here quickly showing you how it works. So generally you have something that pushes a work unit to a set of workers. It can be threads, can be processes, can be some service, doesn't matter. And then all those workers, once they finish processing this work unit, will push it back to the puller. And this is just a way to parallelize work in Zeromq. This also, I've used it also in the past just to have a set of things that produce into one sink kind of thing. But anyway, this is the main use case, and I'm gonna show you how you can have it. So yeah, this is me and my beautiful face, of course. But let's come here to the code. So first, let's tackle the pusher. So this is just the thing that will push work. It will not do any work. It will just push what work needs to be done. So I have a context, and so we need to create a pusher socket, Zeromq socket with the context, and the type is going to be Zeromq push, like so. The pusher, so in our previous diagram, what I didn't show is that the pusher will bind to an address, the puller will bind to an address, and then the worker will have a pusher and puller socket, which will connect to those two. So the pusher and the puller are like kind of the static endpoint in our network, and the workers, they can come and go. So you can have 50 workers, but then 1 hour later decide, oh, I don't need that much, let's reduce it to 30 and it will work just as fine. So anyway, it's this, so Zeromq bind, we're gonna bind it to pusher, and then Zeromq TCP, localhost 8080, like so. And we will say that the payload is a random number between 1 and 999. Then we will just push that over the push socket, like so. And this payload will just be the number of milliseconds we pretend to do work on the worker. So that's gonna be it. Size of a payload. Like so, 0 flags. And let's sleep 1 second between all the messages, like so. Then we're gonna do the puller. So no, what's the pull? We cannot type the puller, which will be extremely similar. Well, actually, no. Let's do it in order. Let's do the worker first. So the pusher now is bound to this endpoint, and now we'll do the worker. So the worker will have a puller, so that will pull stuff from the pusher. So Zeromq socket with the context, and Zeromq puller, no, pull as the type. Then it will have a, I can type apparently, boom, 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 boom. It will also have a pusher where it will push the finished job. Again, it's push, like so, and then these will connect to, so the puller will connect to what we said before, so localhost 8080, like so, and the pusher, well, we'll say that it's at 8081. And so this will just, yeah, receive the work. This will just, yeah, do something like payload, and then Zeromq receive from the puller, it will receive into the payload, size of payload, with 0 flags, and then we will say something like receive the work for X milliseconds, something like that, payload, and then we will do use sleep payload times 1000, since use sleep is in microseconds, and let's just send the response, which will be as printf important work done for, again, the number of milliseconds like so. Yeah, sure. Except I have to specify the string first, and I have to specify the payload here. And we will send that to the pusher, since we finished the thing. CRLN response zero flags. Except I do need the null bytes, and I do need as well the string header. So let's do that. So that way the pusher produces jobs that it sends to the worker. The worker receives the job description. In this case, it just sleeps because it's an example, but it should do like actual work. And once it's done doing the work, it will send it back to the puller. So let's do that. I forgot to close all my sockets, but it doesn't really matter. I guess like so. And let's tackle the puller. Up. So let's copy paste some stuff to be a bit quicker. So the puller, and it will bind on 8081 like so. And we'll just do it simple, where we'll just have a buffer, and we receive from the puller into the buffer size of buffer 0, like so, and we just printf received something buffer, and we trust everything. Let's close the puller. So let's try to demonstrate that. So let me quickly do gcc the puller with Zeromq, and we will output it as puller, like so. Let's compile everything. That's gonna be a bit tedious, but let's do it anyway. Worker with Zeromq, and it's gonna be the worker, like so. Okay. So let's first of all start the pusher, which will publish jobs, and for now the jobs will be published, and there's a queue in each one of these sockets, and this queue will be filled. And the behavior when the queue is filled for a pusher socket is to just block. So it will block the process. So by default it doesn't drop any message, which is nice if you have work but you don't want to lose to like not do the work. So anyway, so now we've started the pusher in the other thing. Let's also start the puller. And so now you see nothing happens because we don't have any workers. But so let's start the worker here, and you see it starts to receive work. And now it processes the work, and the puller also receives the work. So now this was a lot of trouble for not a lot of things, but you can see that now I can just start another worker, and now they both share the work. Well, it doesn't show as good as I would like to, so let's include an index in every piece of work. I mean, I'm gonna do it in a very hacky way, but yeah, don't do this at home, kids, as they say. I'm just gonna have an index like so, and the index is gonna increment every time. And because I don't want to mess around with multiple message, I'm just gonna include the index directly into the payload. And that looks very weird, but basically I'm just having the number of milliseconds, and then right after I have the index. So let's have the worker here, and then the payload is going to be this, and then the I is going to be payload, but shifted by 12, and then payload is going to be ended with itself, but no, not itself, by just 1, this, and -1 to have a mask of 11 bits, like so, and now we can just print the index here. So let's do the GCC like so, and the pusher like so. So let's restart the pusher. Let's restart the puller, and now we should be able to it looks a bit messy, but if I start a worker, now we have an index on every work unit. And if I start, yes, the other worker, we should see that now they're like, the jobs are evenly distributed amongst the two. So every odd jobs goes to this one, every even jobs goes to this one. And I can have as many workers as I want to. And now, like, every 3 jobs will be distributed to every third worker or something like that. So yeah, this is kind of how it works. Of course, yeah, here it doesn't show, but in my pusher, I could increase the number of message, let's say by 3. Yeah, about 3. And so let's now gcc, let's recompile the pusher and restart the pusher, and now we can see there is a bit more jobs, but they're still evenly distributed between the workers. And oh yeah, by the way, I just showed you that, and like the pusher can go away and then come back, and the worker will automatically reconnect. So that's also a nice thing. So anyway, that's just that's it for the most part of pusher puller. What I didn't show you in my initial picture is that you can chain these as long as you want. They call it like kind of the push-pull pattern or the pipeline pattern, because technically any pusher can connect to any puller and vice versa. So like you could have something that produces jobs, but you could have 3 things that produce different jobs. You could have 11 workers here, and then this 11 workers go into another 3 workers, and then at the end you have, I don't know, 2 different things that pull different jobs, and all the messages will be evenly distributed between all the layers of your pipeline. So anyway, that's about it for this video. I hope you learned something, and I'll see you in the next one.